We'd like to talk about the rate of change of blood alcohol concentration. There's this cool experiment from the 70s where researchers measured the blood alcohol concentration in 8 fasting males after rapid consumption of alcohol. And what they found was that the alcohol levels went up very quickly over the first half hour or so, and then they gradually declined as it was washed out of the bloodstream. Now, if we look at this initial increase in the blood alcohol concentration and plot it over here, this axis is time, this is blood alcohol concentration. The units for time are minutes, and the units for blood alcohol concentration are milligrams per milliliter. We see that there's an increase, as shown by the curve there. Now, we might be interested in how quickly the blood alcohol levels are increasing. So we could measure them, say, at 10 minutes and at 20 minutes. And if we wanted to know how quickly they were increasing, we'd draw a secant line through the point 10C10 and 20C20. And then we'd look at the slope, M, of the secant line. So let's go ahead and write that up. And so this would be the average rate of change over the interval. And we want to go between 10 and 20 is M is equal to C20 minus C10 over 20 minus 10. That would be the rise over the run. And it turns out to be, from the experiment, 0.00358 milligrams per milliliter per second. Okay, so that might be our answer, but then we could ask ourselves, what happens if we, for example, use a 5-minute interval? So let's suppose we look at 15 here, okay? And we can put the point 15, C15 on the same graph, and we can draw a secant line through the point 10C10 and 15C15, and it's going to have a different slope. Okay, so on the interval between 10 and 15, the slope is C15 minus C10 over 15 minus 10. And that gives us a different number for the slope, and it turns out to be 0.00529 milligrams per milliliter per second. Okay, and as you can see, the dotted line here has a steeper slope than the dashed line. And so we'll put in the slope here. So on the top one, the first one we did was 0.00358, and for this one we have 0.00529. And so you might ask yourself, what happens if you keep going and taking a smaller time interval over which to compute the slope? And that's what we're going to do in a moment. But before we do that, let's just write the equation for the line, or I should say the secant line. And so we write the equation for the secant line. And we'll call this case A and this case B. And so we'll do the secant line equation for case A. Okay. It's simply C minus C10 divided by T minus 10 is equal to the slope, which is 0.003 0.58. And so we can cross multiply by t minus 10. So we have c minus c10 is equal to 0.00358 times t minus 10. And then we can add c10 to both sides to get c is equal to c10 plus 0.00358 times t minus 10. So this is the equation for the secant line. And so we know how to write the formula for the line, but now we want to think about what happens when we take a smaller and smaller time interval over which to measure the slope. And so we're going to go to a time interval of 1, and then 0.1, and then 0.01, and see what happens to the slope of the secant line. So the average rate of change from t equals 10 to t equals 10 plus h is just the rise, c of 10 plus h minus c of 10, over the run, which is h. And that'll give a slope. And so we can do this experiment. We looked at the case h is 10 and just a moment ago, and also the case h is equal to 5. So if we choose h is equal to 1, we're getting in a little closer. We get 0.00703. We can also choose h to be negative. And so 10 plus h is below 10. And in that case there, we get 0.00804. If we choose 0.1, we're getting even closer. And you can see the numbers are getting closer together. And then when we get a very small increment, 0.01, we get the slope of 0.00751 and 0.00752. So our slopes are coming together, and they're good to about 3 digits. And so if we think about the instantaneous rate of change as h goes to 0, we write that m is equal to c prime of 10, which is the limit as h goes to 0 of the slope formula, which is c of 10 plus h minus c of 10 over h. And so we know that this is approximately equal to 0.00751. And so if we want to put this in the tangent line formulation, we write that the tangent line is a line going through 10 C10, and it has this given slope. And so we write C minus C10 over T minus 10 is equal to 0.00751. And so we can rearrange this to be C is equal to C10 plus 0.00751 times T minus 10. And that's the equation for the tangent line. And I'm going to draw the tangent line on this curve over here. And here's the point 10, C10. And the tangent line is the one that goes through the point and has the same slope as the function. So this is the tangent line here. And the tangent line is given by the formula right here.